So hello everybody, welcome back to the Arduino Zumo robot setup video. Today I'm going to be walking you through what Zumo did, or whoever made these examples did, to make their robot follow the line, and we're going to go through it together and we're going to understand it. But first, we've got to install all these libraries. You can just copy and paste it, or I'll do the first one with you. You go include, and then you type in where you want it. So make sure you do the two little arrow things and a semicolon, and then whatever library you want. Now this has to be in a certain folder. It has to be in the libraries folder, otherwise it won't turn red, and then you know it doesn't work. If it turns red, you know that it's included. But I'm just going to copy those ones. I'm going to put them there so you can pause the video or copy it if you have the two examples open. They're exactly the same. It's going to be exactly the same until the episode after the next one, and where we're going to modify it a little bit. But for now, we're just going through and understanding it. So after we do this, so I'm going to make a note there. Install the libraries. We have to install the libraries, so make sure you do that. And then we're going to define global variables, so var. Define the global variables. Alright, so the global variables we're going to use is going to be Zumo buzzer, so that's referring back to the library that we just imported, and we're going to call it buzzer. We're going to do another one called Zumo reflectance sensor array. Should turn red, but it didn't, so we'll fix that up in a minute. Oh, that's because I put a capital there. We can call this anything, really. Just to keep it simple, I'm going to call it the same thing, but realistically, you could call it anything you wanted to. You could call the buzzer noisemaker. You could call it whatever you want. You just got to make sure the library is the same as the libraries you just installed, pretty much. I'm going to copy this down one more time. Okay, so this says push button library. So like push button, that's a library. We're going to call it button, and then you just got to add this little bit here so it knows what it's referring to within the library. So it knows what button you got to press, because there is a little switch and stuff on the robot. I'm guessing that's just for hardware reasons. And then you do need to define the last error global variable, because it uses it in the void loop. And if you don't define it, it's not going to know where to replace the number. So just set it to 0, set it to default. It has to be set to 0. You cannot change that. The only one you can change is well, you can change the black ones. Actually, you can't change the value. Anyway, so moving on. I would suggest not changing it, but yeah. Okay, so we've got a max speed now. This is another global variable, so we've got to define our max speed variable, which is an constant number. So const stands for constant, and then integer, which is a number. Well, it's a variable, but it's a number variable. And we're going to call it max speed, and we're going to make it 400. Now 400 is as fast as your motors can go. Any faster, you're going to burn them out, or it's just not going to work. So I would suggest not going even 1 over 400. If you want to and break your robot, go for it. I'm not going to stop you. I cannot stop you, but I would not suggest it at all. So please don't do that, and then blame me for it later, because I didn't do it. I warned you. Alrighty, so we're going to move into the setup. We're going to do that first little bit now, and the setup. I'm going to leave the loop for later on. Now setup, we've got a player sound. So buzzer, that's the variable we defined before. Play is the command we're going to give it, and then we're going to have a series of notes that we want it to play. So make sure you have a semicolon after every single one. See how I'm making semicolons? Make sure you don't forget them. Check yours. Make sure they have it. Otherwise, it's not going to work. When we go through and troubleshoot it, when we go through and run dice, knock sticks, it is going to tell you when it's compiling. It's going to tell you that there's an error, so you can fix it up then. But most commonly, it's just because you haven't got a semicolon. Make sure you do. Now, these can be any series of notes. So over here in the line follower example, it's got this little arrow thing, which is a gap. So that's like break for the next note. And it's got G32. So that's actually G and then the 32nd octave, but that's also the time it takes to play as well. So I'm actually going to go C7. I'm going to go C7, arrow, D7, arrow, E7, arrow, F7, arrow, back down to E7, arrow, D7. Oops, I did that wrong. Sorry, I'm pressing buttons here. D7, arrow, 7, arrow, and then C7, arrow, and that will play a cool little doodle-doop. It will go like doodle-doop. It will be like a trill. That's going to sound cool. That's what I want. You can change that to anything if you want. If you don't know what you're doing, just change it to G6. It can just be a flat tone. or you can experiment with it if you want. You can change that inside these little bunny ears to whatever you want, so that's going to be cool. Let's move on down. Reflectance sensors. So that has to be the same as what we defined it up the top. Sensors. That has to be the same as what we defined it as a global variable before this loop. Remember that because it will not work if it doesn't, but again, it will spit out a number. We're going to give it a command, which is init, which means initiate. Make sure you have 2 brackets and then a semicolon. We're going to tell the button, so that's another global variable, to wait. So we're going to give it a command to wait for button, which pretty much means wait for the button press. Why didn't that work? Wait for button, because I have 3 T's. So wait for the button press, and then you're going to pin mode. So pin mode is another command. Pin mode for number, so pretty much pin number 13, you are now outputting a signal. So you put it to output, that's what that line means. And you're going to go digital right, so that's like telling it to what signal to do. So the signal for pin number 13 is high, which means it's on because it's an LED. It is defined before it's defined in the I think it's in the sensors. I don't know. It's defined in one of the libraries as being pin number 13. So what that's doing is turning the LED on. It tells it to turn on. You can change it so it flashes when it makes noise. Stuff like that. We'll do that later on when we modify the code. I'm just going through it at the moment. Alrighty. We're now going to give it a delay. Just give it time to think pretty much. You don't want to overthink it or like overload it. So just give it a moment to initiate that bit, do that bit. Okay, so the code now is defining a new integer, which is a new number. So defining a new variable. So value I is a number. That's what that's saying. And then we've got a for loop. Now this is where it gets a little bit confusing and a little bit tricky. So the for statement, sorry, for I. So remember that's a number equals 0. Or, so we've got a little comment here, or like I is less than 80, or I is equal to 1, so that's like I plus plus means I 1. A little bit of a loop here. Make sure you have those 2 little brackets. You don't need a semicolon for the loop, for the statement, sorry. So that pretty much says, if, it's not an if statement, but it's similar, if I equals 0, or I is less than 80, or I equals 1, do this. And now we're going to write some if statements. So it's now like it's going to be like an if within an if. So this if statement says, if I is greater than 10, or I is less than 30. So if it's greater, oh no, that's and means and. So if I is greater than 10, and I is less than 30, do what we're going to write below, but we have to write just one more before that. So underneath the backspace and above the enter, 2 of them, that just extends the statement. Another bracket, if I is less than 50 and less than 70, so greater than 50, sorry, and less than 70, less than or equal to 70, double bracket at the end, do this. So we've got to open up that one. Go back like that. Tab that in. Cool. I'm just making my code nice and neat. I would suggest making neat code. Okay, do this. So motors, set speed. So this is calibration. So motors, that's the variable we defined before. Set speed, that's its command. Set speeds to -200, so that's the left one, and then 200 for the right one. So that's going to make it turn left. If you can imagine the right one's turning faster than the slow one's like braking. It's like a tractor. It's going to turn. And then we've got a little bit of an we've got an else if here. So I'm going to go back else, and then tab back in motors. So that's pretty much saying if I is not greater than 10 and less than 30, or I is greater than 50 and less than 70, do the one we're writing now. It's like if not, pretty much, so it just reverses the if statement. Turn the other way. So this is just calibrating. It's making sure the numbers it knows how to read them. So it's reading it and saying, look, if this number here is this first one, if it is this if statement here, do this one. or if it's not, do this one. So that's what that bit's doing. It's just a little bit of math. A little bit confusing, I know, but just roll with it. And then we're going to give it another delay. In the line follower example, it explains what it is, but you don't need, it's a delay, that's all you got to know. We're going to know that as a delay. And then after that if state, so that's an if statement, after that for, is it after the for statement? Yeah, after this for statement here, why does the if not have brackets? Okay. Let's get rid of them too, because apparently we don't need them. I thought we would have needed them, but anyway, after the for statement here, so just here, bracket, bracket, we'll go back one, oops, back. So we're going to reset the motors, so motors dot the command set speeds, so that's setting the motors as a speed 0, so it stops turning. It will do this in a matter of seconds, but it's going to turn it so it's in the middle again, so that's back to default. So now it's calibrated the motors, which is good. That whole bit there that we just wrote was calibrating the motors. Enter, enter. Now we've got to play the buzzer to say it's finished calibrating the motors. So buzzer.play, so that's our global variable with a command, that's play. I'm just going to copy that buzzer play from what we did up the top, that little tone there, because it's exactly the same. You can literally copy the whole thing, put it down. Buzzer.play, you can change it if you want to know what a different one is, but I'm going to keep it the same. We're going to wait for another button press, so button dot, is it press? Yeah. No, wait for button, sorry. Wait for button. Yeah, so button dot wait for button, so that's the variable button, wait for the command, which is wait for the button, and then after it has got the buzzer, got the button, buzzer dot play, and then we're actually going to make this a new sound like they have, but we're just going to make this a very generic G6, and it's just going to hold that G6. That's what I told you to do before. If you don't want to, you can change that to whatever you want again. And then while, so this means while the buzzer is playing, so everything inside this bracket here is while the buzzer is playing, do nothing. That's what that means. Those two in here, you can tell it to do something if you want, but while the buzzer is playing, do nothing. And then when the buzzer stops playing, it's going to finish that loop, and that's the setup done because it only runs once. So that's actually our setup there, finished, and we've converted it over. Now let's go. I'm going to go through it again. I know I explained it, but we're going to go through and comment it. I would make the comments as well, just like we did up here, just so you know what you're doing and what I'm saying, because you know, it is copying an example, but we're going to modify it to make it our own. But we got to be able to understand what we're copying. And it is open source. It is included in the program and in the examples. Again, there's links in the previous videos, but we got to understand it if we're going to use it. So let's just go through it. This means play sound through buzzer. So you kind of you read this one backwards. Play this sound through the variable buzzer. Then down here again, and then this says initialize sensors. So there's our variable, and then .int. So the red one is our commands. So that's initialize reflective sensors, which we defined up here, remember. This one says wait for a button press. So the button is again defined up here, and that's the command, wait for the button press. This means pin 13 is an output pin. So that means that the number 13 is an output. What this one means is change signal on pin 13 to high. So obviously this is an analog signal because high means on, low means off. There's only two different ones. Maybe it is a digital, I'm not too sure, but they've only written high and low. So they're using the digital signal as an analog signal anyway. So change signal to pin 13 to high, which turns on LED. So that turns on LED because number 13, so pin 13 is LED because the pin 13 is defined as an LED in the other one. This is just a simple delay for 1000 milliseconds. And then this is define number variable, because integer is number variable I, because that's a number. Remember, an integer is always a number. And then this is a math loop for motor calibration. So this is another, not a loop, sorry, statement. It's statement 4. So this 4.1 means, so we'll write this down as well. So pretty much for I for if I is equal to 0, less than 80 or 1, do this little if statement here. So that means for okay, we're just gonna have if actually. If I is equal to 0, less than 80 or 1, do this if statement. So the if statement says if I is greater than 10 and less than 30, or, so there's two little lines there, so these two little lines is or I is greater than, I can't spell, but that's alright, you get the point, greater than 50 and less than or equal to 70, do this little bit here, which means oh, sorry, I'm trying to get there, which means set motors to negative 200 on left or 200 on right. That's what that one means. And then the else means if not, set motors to 200 on the left and negative 200 on the right. So I'm going to change that to and. So hopefully that little bit makes sense. I know it's a bit of a confusing little jumble here. Oh, and then delay for 20 milliseconds times, it's times something, but we'll just go delay for 20 milliseconds. Don't have to worry about that. It's a simple delay. But I know it is confusing, so let's just go through it one more time. So this for statement says, if I is equal to 0, less than 80 or 1, do this. So then we go down. If I is greater than 10 and less than 30, or I is greater than 50 and less than 70, do this line here, which is set motors to negative 200 on the left and 200 on the right. So that's if this is true. But if not true, so if it is not true, if this is not true, set the motors to 200 on the left and negative 200 on the right. And that's just going to calibrate it so it knows what math it's doing, and it knows there's basic math we need it to know for later on. So that's a good thing, and then delay it for 20 seconds. Awesome. Then we're going to go reset motors to default, which is 0, 0. That's straight ahead. It's going to play a buzzer sound to notify end of calibration. So that's going to notify us of the end of the calibration. It's then going to wait for user button press, and then it's going to play buzzer sound to signal start of void loop. And that's it, and it's only going to run that once, and that is our setup done, explained in English, and that's all done. So I'm just going to make a note up here, only once. So I hope that all makes sense. I'm sure it does. If not, you can download my code and go through it, or just rewind the video. My code will be in a paste bin, and that will be linked down below. I hope you enjoyed it. I hope you I'm stumbled for words. It's really hot. I hope you enjoyed it. I hope you know what I'm saying. If not, and you're on YouTube, shoot me a comment. If I'm not on YouTube, then I can't help you. I'm very sorry. But go to my YouTube video. Maybe someone else has made a comment, and I can help you out a little bit. So I hope you enjoyed. We have installed the libraries. We've defined the global variables. We've set the max speed, and now we've set up the void setup. So if you want to copy this code here, go ahead, go to the paste bin, but in the next episode there will be an updated version, so it will probably have the void loop as well. But just look at the setup if you're having a bit of trouble. Stick around for the next one, because the next one we are going to go through the void loop. Hope you all enjoyed, and I will see you next time.